Autonomous systems process data and execute decisions at a scale and speed bypassing traditional human oversight. Without boundaries, the resulting output is entirely unpredictable. We have to discard the idea that AI ethics is a subjective philosophical debate. In the context of system auditing, it is a rigorous risk management framework. Organizations routinely fail to govern their algorithms because they treat ethical oversight as an ad hoc, localized problem to be solved by individual engineers, rather than a structural requirement of the business. The Independent Audit of AI Systems, or IAAIS standard, provides the operational solution to this failure. Ethical oversight requires more than the good intentions of a development team. It requires a verifiable infrastructure of trust, built directly into the organization's operating model. Effective auditing of an AI system starts at the level of corporate governance, well before an auditor ever examines a line of source code. An infrastructure of trust is the formalized system of checks, balances, and reporting lines that an organization must implement before deploying autonomous systems. To evaluate this infrastructure, an audit examines three interconnected pillars: the organizational hierarchy, a shared moral framework, and a technical bias pipeline. This structural foundation provides the only mechanism for verifying accountability in autonomous systems. The baseline requirement for the IAAIS standard is the creation of a standing, fully empowered ethics committee. This chart shows the structure required to empower the committee, starting with the board of directors. Traditionally, the CEO reports directly to the board, but this standard mandates a bypass. The ethics committee reports directly to the board of directors, bypassing the CEO entirely. This bypass is a structural necessity. It ensures true independence by insulating the committee from executive product timelines and financial pressures. If an ethics committee reports to the CEO, it is structurally compromised. It functions as a public relations exercise rather than a legitimate governance body. An independent committee cannot make decisions based on the individual moral compasses of its members. It must operate based on codified, auditable rules. This diagram shows how the Ethics Committee's mandate is split into two formalized documents, the Code of Ethics and the Code of Data Ethics. These codes have strict structural requirements. They must be internally coherent, publicly disclosed, and explicitly tied to relevant legal frameworks. To ensure organization-wide awareness and compliance, these documents are embedded directly into the employee handbook. Together, these codes act as a shared moral framework. Every corporate action and algorithmic decision is measured against this fixed, verifiable standard. There is a pervasive industry misconception that an AI auditor's job is to determine whether a system is universally right or wrong. The actual core function of the Ethics Committee is to produce what is called the Ethical Risk Analysis, or ERA. The ERA is defined here as a systematic study and collection of instances of ethical choice across the entire lifecycle of the AI or algorithm. When evaluating these instances, every decision is evaluated strictly within the context of the Code of Ethics, not personal opinions. The final output of the ERA is the exhaustive documentation of the residual risk stemming from those decisions. These audits provide the board of directors with quantified risk profiles, creating a basis for governance rather than offering moral validation. Once the governance structure is in place, the technical execution of the audit begins, specifically concerning the evaluation of bias and protected categories. Bias cannot merely be audited by looking at the final output. This document outlines the IAAIS three-step decomposition: data, architectural inputs, and outcomes. Phase 1 examines the data. Auditors look for historical embeddedness, the representativeness of the sample, and whether the statistical characteristics are sufficient for the task. Phase 2 examines architectural inputs. This is where the audit evaluates pipeline quality, human-in-the-loop dependencies, and concept drift occurring during model construction. Finally, Phase 3 evaluates outcomes. This phase measures the results generated by the system against strict fairness metrics. Outcomes are measured using specific metrics, such as the 4/5 rule, to detect disparate impact against protected groups. Protected categories like gender, race, and age act as the critical triggers for bias remediation and dictate how special category data is handled. Breaking the audit down into these 3 steps allows investigators to trace algorithmic failure back to its exact root cause, whether it was a flawed training dataset or a shift in the architectural inputs. The technical bias pipeline and the executive governance structure do not operate in isolation. They form a single, unified accountability loop. The technical outputs from the 3-step bias pipeline are fed directly up the chain to the Ethics Committee for review. The Ethics Committee evaluates this technical data exclusively through the lens of the established Code of Ethics to determine the residual risk. This evaluation forms the final ethical risk analysis, which is delivered directly to the board, ensuring the organization is held accountable to its own shared moral framework. When an adverse event occurs, this unified system allows for total traceability across the AI lifecycle, pointing directly to where the failure happened and who is responsible. The IAAIS standard successfully transforms abstract ethical philosophy into a concrete, auditable infrastructure of trust.